So here we're going to find the equation of the tangent line and the normal lines to the graph of f at the indicated point. So we've got a function sine x divided by e to the x, and I want to find the tangent line and the normal line at this particular point here. So recall if you had some graph like this here, and you wanted to find the tangent line at this point right here, that tangent line would look like this, where it just touches the graph in one spot right there. It tells you the slope of the tangent line. And so that's one thing we're looking for. The other thing that we're looking for is the normal line, and the normal line is exactly perpendicular to the graph at that indicated point. So that's the normal line, and this is the tangent line. Okay? So those are two things that we're looking to find the equations of those lines. So in order to find an equation of a line, we need to think about the point slope form of a line. So y minus y1 equals m times x minus x1. Now, why do we focus on the derivative? Because the derivative tells us what the slope is at that particular point. Okay, so if I plug in pi over 2 into my x, I'll get that slope at that point, and then I just plug in for x1, the pi over 2, and I plug in for y1, this 1 over square root of e to the pi. Okay? So, let's get the derivative here. The derivative is a quotient, so I'm going to use the quotient rule. Low d high minus high d low all over the square of what's below. So what does that get me? That gets me, well, what's the derivative of sine? The derivative of sine is cosine. So this is e to the x cosine x minus, and the derivative of e to the x is just e to the x. So it's e to the x sine x all over e to the x times e to the x. I write it like this because it's squared, but also because I see that I can cancel all those e to the x's there. Okay, so let me give you the prettier version. All right, now f prime of pi over 2, I'm literally going to take pi over 2 and plug in everywhere I see an x. Okay, so when I do that, I get e to the pi over 2 times cosine pi over 2 minus sine pi over 2 times e to the pi over 2 divided by e to the pi over 2 times 2, and that cancels to get me e to the pi in the denominator. Now here, cosine of pi over 2 is 0, but the sine of pi over 2 is 1, so that's negative 1. So this part goes away. The first part goes away because the cosine gives me 0. So I get negative 1 e to the pi over 2. Now, if I have pi over 2 in the numerator exponent, and then pi in the denominator exponent, guess what? It's kind of like saying square root x over x, right? If I simplify this, this becomes 1 over the square root of x. So that's what's going on there. You can use your property of exponents if you're having trouble seeing that. Look, the negative 1 just comes out front, but then dividing, you subtract the exponents. Pi over 2 minus pi gets you negative pi over 2. So if e to the negative pi over 2, this goes down to the denominator because it's a negative exponent. Okay, so my slope at the point, pi over 2, comma 1 over e to the pi over 2, is equal to negative 1 over e to the pi over 2. So the tangent line, using my point slope formula, y minus y1 equals m times x minus x1, where literally I take the y1 here and I plug it in here. I take the x2 here, the x1 here, and I plug it in here. And then I take my slope and I plug it in for m right here. And voila, I have my answer right here. This is the equation of the tangent line. Okay? So if they don't ask you to solve for y, then you're good to go right there. You don't have to do any other work. Right? If they ask you to solve for y, you'll need to clean it up a little bit. But that's it. So tangent line right here. Now, the normal line. The only thing different between the tangent line and the normal line is the slope. If the slope is equal to -1 over e to the pi half, then the perpendicular slope is the reciprocal of this, so e to the pi over 2, and then the negative reciprocal, so the negative of a negative is a positive. Okay? So we just do the reciprocal, and we do the negative of that. So this is literally the only thing that's changing. So I still have this piece here, that piece there, and now my slope becomes positive e to the pi halves. Okay? And that's the equation of the normal line right there. Now, I want to find the values of x where the graph of the function has a horizontal tangent line. So I'm given this equation right here, 1/3 x cubed plus 2x squared plus 3x. So this is a cubic. This cubit looks like this here. So find the values of x where the graph has a horizontal tangent line. When I think of a horizontal tangent line, when I'm looking at this, where am I tangent at? Well, it looks like right here probably be a tangent, right here be a tangent, right? Where the slope is 0. Okay, horizontal lines have a slope of 0. So that's the fact that we're going to use to help us figure out that the horizontal tangent line, we set the derivative equal to 0 and solve for x. Remember, horizontal tangent lines have a slope of 0. So what is the derivative of f of x? The derivative of f of x, okay, I have 1/3 x cubed, so I'm going to bring the 3 down front and then subtract 1 from the exponent, and I'm going to bring the 2 down front and then subtract 1 from the exponent, and then I'm going to take the derivative of 3x and just get 3. The 1 comes down and then it becomes x to the 0 power, so the variable goes away. If I simplify this, set the derivative equal to 0, because I'm solving for slopes, x values that give me a slope of a tangent line equal to 0, so that means the derivative equals 0. 3 times 1/3 is just 1, so that's x squared. 2 times 2 is 4, so that's 4x, and then plus 3. Well, hopefully this is kind of ringing a bell for you here. You've got a function that is a cubic, but the derivative of that function is a quadratic. Okay, that's by design. All right. I can factor this quadratic here, and looks like it's a trinomial, so you can do trinomial t-chart. You're having trouble doing that, go to college algebra. Watch the video link for the playlist, and I think it's like 1.5 or something, factoring AC method, and it'll show you exactly how to do that. But I want something that multiplies to 3 and adds to 4, and so 3 times 1 gets me 3, and 3 plus 1 gets me 4. So it's x plus 3, x plus 1. And so what I do here to find the x value is I set each of these pieces equal to 0. I solve for x, I get x is -3. And at -3, we're right here for an x value. The output, if I plug a -3 in for f, my output is 0. Okay. And so the slope of that tangent line right there is clearly 0. And then solve for x equal to -1. I get, plug in a -1 into my function. If I plug in a -1 here, I have f of -1 equals 1/3 -1 cubed plus 2 times -1 squared plus 3 times -1. That output is going to be a fraction. When I type that in, I get f of -1 to be, it looks like 4/3. So that's where my output is. Now that slope right there, once again, has a tangent line slope equal to 0. Okay? Now, one thing I want you to note when you're going through these problems in your homework, the only way that a fraction is equal to 0, so I'm talking about like a rational, is whenever the numerator is equal to 0. So say you took some derivative, right? Or maybe we had, f of x equals, 2x plus 1 over x squared minus 1. Okay? So the only way that this fraction is equal to 0 is if, and so maybe that's the derivative, right? We took the derivative, this is what we got. And so we set it equal to 0. The only way that that's equal to 0 is if the numerator equals 0. And you can think about it, 0 is like saying 0 over 1. And if you want to, you could cross multiply. And if you cross multiply, you have 2x plus 1 times 1 equals x squared minus 1 times 0. But guess what? This is just 0. Anything times 0 is 0. And then so you solve, subtract 1, you get 2x equals -1. X equals -1/2. So if you just remember the fact that the only way that a fraction is equal to 0 is if the numerator is equal to 0, then you can skip all this and just take the numerator and set that equal to 0, as you can see right there, and you'll have your answer. Okay? So just a little, trick of the trade for you. All right, guys, good luck.